This section actually should be review. All we're going to do is say that the three rules we had for handling properties of exponents, which was the product of two with the same base and exponents, we add the exponents. The quotient, when we divide, we subtract. And then when we raise exponents to exponents, we multiply. Those three rules apply with rational exponents as well. Okay? That's all this section is. So if I have x to the 2/3 times x to the 4/5, what do I do with the exponents? You add them. So I'm going to the side, I'm just going to write 2/3 plus 4/5. Okay, now I've got to get the common denominator, so this becomes 10/15 plus 12/15, right? Do you guys remember those who had John Baylor? When you have a fraction like this, an easy way to do it is, he calls it the crisscross method. You multiply these together to get your denominator, and then you multiply 5 times 2 and 3 times 4, and that gives you 10 and 12. And then you can add. So this is 22/15. X to the 22. Yep, 22/15. Hello. Anyway, you get it. 22/15. Okay, so we add them. We subtract when we divide, and when we have one raised to a power, we multiply. So I'm going to do one example of a complicated one, and then let you get to work. So let's do this one. 75d to the 18/5. My board is just acting up today. 18/5 over 3d to the 3/5, all raised to the 5/2. Okay, so the thing to remember here is each term inside here must be raised to the 5/2.
Right.
So we have 75 to the 5/2. We have d 18/5. What do I do with the exponents?
You need to, you're just multiplying.
Multiplying them, because when I raise an exponent to an exponent, I multiply. When I multiply two things together, I add the exponents. Okay? So 18/5 times 5 over 2. The 5's cancel. 18 over 2 is 9, so it's d to the 9th. 3 to the 5/2. And then I have d to the 3/2.
15, which is 2.
Yep. Okay, now, what is, I could have first, maybe that would have been a better way to go, simplify what's inside. So let's do it that way, rather than jumping to, because 75 over 3 is what?
75 divided by 3.
Uh-huh.
That's 25.
25. D to the 18/5 over d to the 3/5 is d to what?
15/5.
15/5, because I subtract, which is 3. Now I raise this to the 5/2. Okay, so this is 25 to the 5/2 times d. 5/2 times 3 is 15/2, right?
Which is
Just 15/2. Yep. Because it's 3 over 1 times 5 over 2, which is 15 over 2. Okay, now,
we need to simplify it more.
yes, because 25 to the 3/2, who can recognize what that is without having to write the root?
It's going to be 2. It's square root of 2 with the 3 inside the
With a 5.
with the 5.
Yep, so the square root of 25 is 5.
Right.
So this is going to be 5 to the 5th, right? And then d to the 15/2. And 5 to the 5th, 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5. 625 times 5?
3125.
Okay. So this becomes 3125 d to the 15 halves. And that's as good as it's going to get.
Sweet.
Okay?
That's easy.
Let's go through the textbook check. If I can find it. Okay, if you've reduced a problem down to x to the 16/9, you should rewrite the improper fraction to a mixed number. False. Exponents are always written as improper fractions, never as mixed numbers. Okay? The expression below would be simplified to, well, this is 7/4 minus 1/2, which is 7/4 minus 3/4, or 2/4, sorry. 7 minus 2 is 5, so 7, this would be w to the 5/4, which is the third one down. Okay, this one I'm going to multiply. So 3 halves times 4/3 is 12/6, which is 2. 3 squared is 9. This one, don't forget you've got to raise the 4 to the 1/2 also. What is 4 raised to the 1/2? 2, because it's the square root of 4. So I know my answer is going to be 2. There's really only one that has 2 on the top, but I need to finish. So x to the negative 2/3 times 1/2 is negative 2/6, which is negative 1/3. Because it's negative, it flips to the bottom, so we have 2 over x to the 1/3. And then the video was not by James Souza.
No.
It was a different guy. And that is it.